This is lesson 5.5, day 2 of solving quadratic equations and functions. So we're going to talk about some different methods for solving and which method is best. So quadratic equations are in the form of your first coefficient, x squared, plus b, next coefficient, x, plus c, and they're all real numbers, a, b, and c. So quadratic equations have two solutions, but it's possible that one solution may be a repeat. So let's go ahead and talk about which method is best. So the first one we're going to talk about is the square root. So there's three things. If it says to solve by square root method, then you're going to want to do the square root. So it doesn't necessarily mean that it equals 0 over here. We could have some where it actually equals a number. So if it's x squared set equal to something, then you're definitely going to want to use square root. So for example, this one, we would do the square root on both sides. So it would be x equals plus or minus 3. And then over here, square root, and we would simplify this by pulling out a biggest perfect square as a factor. Don't forget your plus minus. So equals plus minus square root 4 times square root 3, which we could then simplify the perfect square. So 2 square root 3 with plus minus in front. So the next one, when there's no middle term, then you can go ahead and solve using the square root method. So add 15, divide by 3, and then do the square root. Get that x squared by itself. So x squared equals 5, then do the square root, so x equals plus or minus 5. And then down here, get that x squared alone by adding 81, and then do the square root. So plus or minus 9. There we go. So next method is going to be factoring. So if it says solve by factoring, then you're going to factor. So look for the easy factorable quadratics where it's just x squared and you have factors of 12 that can add to get that middle term, which in this case would be negative 6 and 2. That multiplies to get negative 12, adds to get that. So it'd be x minus 6 and x plus 2. And then set these each equal to 0 and solve. Add 6, so x equals 6, minus 2, so x equals negative 2. Or when it's already factored for you, then you can just go ahead and put your parts equal to 0 and solve. So here is negative 5, add 8, x equals 8. Or when your constant is missing, the c is missing, then you can go ahead and factor out a greatest common factor x. So 3x minus 1 equals 0. Then set your both parts equal to 0. So if x equals 0 is 1, 3x minus 1 equals 0 is the other. So add 1. And then divide by 3. So 3x equals 1, divide by 3. So 1/3. X equals 1/3 as well. And then the last method is going to be the quadratic formula, and this is the one that's kind of your go-to if it's not factorable, if you're going to end up with saying rounding, if it says use the quadratic formula. So something that looks difficult or that you're having trouble finding factors of it. So here we're going to start off with opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then simplify under that radical there. So 9 minus multiplying all of this to get minus a negative 160. And then 2 times, oops, forgot to fill in the a there, is 10. So 2 times 10 is 20, and it's 3 plus or minus. And then we wind up with 3 plus or minus the square root of 169 over 20. And we know that 169 is a perfect square, it's 13, so it's 3 plus or minus 13 over 20, which then we could simplify. 3 plus 13 over 20 reduces, and we have 4 halves. And 3 minus 13 is negative 10 over 20 would be negative 1/2. So I'll just put a comma, negative 1/2. There we go. So the quadratic is not factorable. So right here, there's no factors of 2 that could possibly add to get negative 6. So again, using that quadratic formula over here, if you can't remember it, labeling our A, so 1, B, negative 6, C is 2. And then we want to plug it into our formula there. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then simplifying. So under that radical, that's 36 minus 8 over 2 with a plus minus 6. So under our radical on this one, we get a 48. Square root of 48. So simplifying that, we could break down the 48 as 16 and 3. So we wind up with 6 plus or minus, the square root of 16 is 4. So if we show you that set, plus or minus square root 16, square root 3 over 2. So the 16 becomes a 4. Last step, look for these three numbers to be able to simplify if there's a common factor, and there is 2. So divide everything by 2 to get 3, plus or minus 4 divided by 2 is 2. And on the bottom, you don't have to put the 1, and we're done. And then anything that has to be rounded, finding all the zeros and rounding means we can't factor, we can't do the square root method, so we need to use the quadratic formula. So make sure you have that memorized. Let's go ahead and take a look at some overall examples here. So I'm definitely going to have you do number 4 because that is quadratic formula, and I want you to practice that. Also going to have quadratic formula on number 6 because if we end up getting that 6 over there, it's not factorable. Let's go ahead and do well, let's go ahead and actually have you start off. Remember, we want to subtract 14 to get it to the other side, so it's going to be a minus 14 and then equals 0. So now I want you to factor this. It's the shortcut method, and then put each set of parentheses after factoring equal to 0 and solve. Number 2, notice that we have a squared, no middle term, so we definitely want to do square root on this one, so I want you to try that one. Over here on this one, there's no c, so remember we want to do the factoring method of pulling out greatest common factor, so it should be the easy factoring for you. Quadratic formula, try that one on number 4. And then number 5, want you to group, use that grouping method, and then put the parts equal to 0 and solve. And then we'll check our answers. I really want you to try these on your own for the practice because we have done examples similar to these, but it's been a while. So look at your examples from above, and please try 1 through 5. And then check your answers when you're ready. All right, so let's go ahead and talk about these answers. So subtracting 14, coming up with the factors of negative 14 that add to get 9 would be negative 7 and negative 2. So putting those into our sets of parentheses, we now can solve x minus 7 equals 0, x minus 2 equals 0. So x is 7 and x is 2. So shortcut factoring method for that. Next, we have something that's squared, no middle term. So add the 25, get that x squared alone. Then you can do the square root. So get this away, divide by 5. Now do the square root. Don't forget your plus minus. Number 3, greatest common factor of 7x. So pull that out. Set the 7x equal to 0 and set the x plus 7 equal to 0. And then solve both to get 0 and negative 7. Number 4, minus 8. Again, we want everything to on the left side to equal 0. So 2 and negative 8, factors of negative 16 that add to get negative 3, oh, none. So that means if there's no factors, we cannot use the factoring method. So we need to go to quadratic formula, which I already told you on this one. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then simplify. Watch your simplification here. 9, then multiply these three numbers together to get positive 64, then add. So square root of 73 can't be simplified, so it's 3 plus or minus that over 4. Grouping method here, pull out your greatest common factor for both sets. You put those greatest common factors together. What they have in common is the second part, or the first part, and then simplify by solving. So add 2, divide by 3. Over here, add 4, do the square root. So we have plus or minus 2 and 2/3. And then number 6, again, getting everything to one side, trying to see if we can factor, but there's no factors of 18 that add to get 5. So you're going to use the quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. And then we're going to simplify under the radical. This here is an imaginary since it's negative, so that negative comes out and becomes an I, and we can't simplify the 47. So negative 5 plus or minus I square root 47 over 6 is as simplified as we can get.